All right, guys, now we're going to roll into Article 100. Article 100 is a series of definitions. That way we have a common language between us and the inspectors and the code book. All right, so we're going to start off here in Article 100 on page 70-27. Now, from here on out, I'm just going to refer to that as page 27, okay? And so page 27, we're going to look for the word accessible. And so we're going to highlight that. So we're going to pull out our highlighters. We're going to highlight stuff that you see that's highlighted up here on the screen. Now, the reason for that are these are test questions that we're seeing on these exams. Okay, so we want to make sure and highlight that so it's easy to spot, easy to recall that information. So we're going to start off here with accessible, and this is accessible as applied to equipment. That's capable of being reached for operation, renewal, and inspection. So if something is capable for being reached for operation, renewal, and inspection, that's going to be considered accessible. But there's also this term readily accessible. And so that's a little bit different, a little bit more nuanced. And so readily accessible, that's capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to take actions such as tools to use other than keys, to climb over or under, or to remove obstacles or resort to portable ladders and so forth. So take a look at me here. And so I was able to grab this code book here. And so this code book right there was readily accessible. I was able to get to it. I didn't have to do anything to get to it. It was right there on my desk. Now, if I take this code book and I stick it into a cabinet, and I have to open up a door in order to get to that, now it's no longer readily accessible, but it's still accessible. So accessible is I can get to it. Readily accessible is it's ready to be accessed. And there's also a term that's used in the code, accessible to qualified persons. That's typically when I have it in a locked enclosure, and that qualified person is a person that has the key. So you got accessible, readily accessible, and then also accessible to qualified persons. Let's move on to the letter B. So here on page 29, we're going to go to bathroom. Now, when you see a little triangle here in the code there, that indicates that there's a change to the wording in here. Now, typically changes are going to be highlighted in gray, but if we're omitting words, there's nothing that's going to be highlighted in gray. It's just an omission. So that's indicated by having a triangle there. All right? And so the first definition we're going to take a look at is bathroom. So bathroom, that's an area including a sink with one or more of the following: a toilet, a urinal, a tub, a shower, a bidet, or similar plumbing fixtures. And then you see this little indication there, CMP2. You know what that means? Code Making Panel 2 is the one who signed off on this definition for bathroom. So really means nothing to you. Now, one of the definitions that we run across is a block. Question on the exam says, when it comes to communications equipment, what is a block? And I would think, hey, that's something that you're punching down on, or some sort of electrical device that we're making connections on. No, that's a square or portion of a city or town or village enclosed by streets, and including the alleys so enclosed, but not any street. And then you also see that this indication here of the 800. Now what that means is that came out of Article 800. That is a definition that used to be in Article 800, but in the 2023 they moved all those definitions into our definition chapter. I really like that change in the code. And then you'll see that this is an indication, it's got a little N next to it, which would indicate that this is new, not a new definition, just a new location for it. Then we're going to jump down to bonding jumper, equipment, and then you'll notice that equipment bonding jumper is highlighted in gray. That's a change from the previous edition of the code. And so it didn't have that wording, equipment bonding jumper, it just said bonding jumper equipment. So that's a change. That's the connection between two or more portions of the equipment grounding conductor. Again, you don't like that definition? Go see Code Making Panel 5. Let's go to branch circuit. Still on page 29, branch circuit, or branch dash circuit. That's really nuanced, right? the circuit conductors between the final overcurrent device protecting the circuit and the outlets. So you'll see here on our illustration, so our branch circuit is going to go from that panel board to the outlet, okay? So that indication there, you may call that something different in the field. That's why we have a definitions chapter here. You may call that the home run. Give me a home run back to the panel board. You know what they're talking about. The code's going to refer to that as the branch circuit. Let's move on to letter C. We've actually jumped a few pages here. We're on page 34, spilling on to page 35. And so we're going to find a new definition. And again, this is not new, just a relocation. This is conduit, liquid type flexible metal, or liquid type flexible metal conduit, right? That's a racewear or circular cross-sectional having an outer liquid type non-metallic sun resistant jacket over an inner flexible metal core. Now, you don't really need to know all that information. You just need to know what the letters LFMC stand for, and that's liquid type flexible metal conduit. And so that's your test question. LFMC stands for what? Liquid type flexible metal conduit. And I can find that here in our definition chapter. We got connector, pressure, pressure or pressure connector. That's a device that establishes a connection between two or more conductors or between one or more conductors and a terminal by means of mechanical pressure without the use of solder. So this is a solderless connection that is a pressure connector. And then we have continuous load. Continuous load, as defined by the code, that is a load where the maximum current is expected to continue for 3 hours or more. So we may have to make an adjustment to calculations based off of the fact that something is continuous load versus non-continuous load. How do we define that? Is it going to run for 3 hours or more? Moving on to letter D here. Now we're on to page 36. A device. A device, that's a unit of an electrical system other than a conductor that carries or controls electrical energy as its principal function. Question on the exam says, which of the following is not a device? And you'll have 3 items that are devices and a 4th item that's not a device, and that is going to be our receptacle box. Okay, that's not considered a device as according to the code. That is not something that carries or controls electrical energy as its principal function. It's there to mount other stuff. We're going to go to letter F. Letter F, feeder. And so the feeder, that's our circuit conductors between the service equipment, the source of a separately derived system or other power supply source, and the final branch circuit overcurrent device. And so here on our illustration, you can see that's going to be between our service equipment and our panel board, or between our generator and our panel board, okay? So this is between our service equipment and the source of the separately derived system, or other power supply source, and the final branch circuit overcurrent device. So it's upstream, basically, of that branch circuit overcurrent device. All right. Some of these definitions are a little bit less complicated than you want them to be. And so a definition for ground is simply the earth. Okay, so you got 4 choices on there. Which of the following is the definition of the ground? And that is going to be the earth. Now, I would never pick that. That's way too simple, right? But that's what the code says, so that's the right answer. We're always going to default to what does the code say? Okay? And so if we don't remember from class what an answer is, what I need you to do is I need you to look it up in the code book and find out what the answer is, okay? 90% of your test is going to be coming out of this code book. Then we'll also have some safety questions that are obviously going to come out of OSHA. And then we'll also have questions that come out of the uglies, mainly calculations type questions where we'll pull the formula out of uglies. Things like series and parallel calculations and things like that. You can bring all 3 of those books into the exam, and I would encourage you to bring every single book into the exam because those answers are right in front of you if you can dig and extract those out of the book. Okay? Going on, grounded conductor. That's a system or circuit conductor that's intentionally grounded. Again, a little bit more simple than you might want to have that explained. That's an intentionally grounded circuit conductor. or an intentionally grounded system. In sight from, or within sight from, or within sight. These are all different terms that are used interchangeably. Basically what that means to us is that I can see it and it's within 50 feet. Let's take a look at the definition. Equipment that is visible and not more than 50 feet distant from the other equipment is in sight from that other equipment. So when the code refers to in sight from, or within sight from, or within sight, what it means is I can see it and it's within 50 feet. Neutral conductor. The neutral conductor, that's our conductor connected to the neutral point of a system that's intended to carry current under normal conditions. So the neutral conductor is intended to carry current under normal conditions. Letter P, page 53. Page 53, letter P, we've got a phase converter. And again, this is a new definition in this article, but it's not a new definition for the code. In previous codes, this was back in our phase converter article. I believe that's article 455, something like that. And phase converters, that definition was back there. Now it's here in article 100. So phase converter, that's an electrical device that converts single phase power to three-phase power. Let's go still in letter P to plenum. Plenum, that's going to be an air handling space of some sort. That's a compartment or chamber to which one or more air ducts are connected that forms part of the air distribution system. So if we're trying to distribute air in a space, that air distributing space, usually a duct or an underfloor space, is going to be considered a plenum. Letter P still, we've got portable. And again, new definition. This is portable, and it used to be applied to equipment. And so they just call that now portable. Portable, that's a device intended for indoor or outdoor use that's designed to be hand carried from location to location or easily transported without the use of devices or equipment. So if I don't have to bring in a forklift or something like that to move this thing, we're going to consider that portable. So if it's hand carryable from location to location, that's going to be considered portable equipment. Let's go to letter S. We're going to go to page 58. Page 58, service conductors. Again, we all know what the service conductors are, but let's see what the code defines those as. That's our conductors from the service point to the service disconnecting means. So here in this illustration, from our service point, which would be that transformer, right, to our basically our weatherhead and down to and including the meter there, that is going to be our service entrance conductors. Also from that meter to that service disconnecting means, that would also be service conductors. So when we're sizing our service conductors, that's what we're talking about. All right, guys, we're going to jump into Article 110. Article 110 is general requirements for electrical installations. We're going to start off here on page 65. 110.9, we've got interrupting rating. And this falls under Part 1 General. So each of these articles, or the larger articles, is actually divided into different parts. This particular part is just general regulations here in Article 110. But as we get farther into Article 110, things will get more and more specific. Okay, so these are just general regulations for electrical installations. And so we're going to go to 110.9, interrupting rating. And we're going to highlight equipment intended to interrupt current at fault levels shall have an interrupting rating at the nominal circuit voltage at least equal to the available fault current at the line terminals of the equipment. And so basically that needs to be at the nominal circuit voltage. So question on the exam actually asks what percentage of the nominal circuit voltage does the interrupting rating need to be? Now when we look at this, we don't see a number there. So that makes that a little bit more difficult for us. But part of what we're going to teach you is how to read and interpret the code. And so interpreting the code is just reading it and seeing what it says. And so in this circumstance, if I'm looking for a percentage, I can just read it and it says it needs to be at the nominal circuit voltage. Now, what percentage would be at the nominal circuit voltage? That'd be 100%. Moving on, page 66, we've got 110.14 electrical connections. And so we've got letter A, B, and C. We're going to jump down to letter C, temperature limitations. Now, temperature limitations for what? It's electrical connections. And so what we need to understand is the context of the code as we're going through. As we're reading things, we can see that it's basically organized by these different code references. And these code references are different subtopics of the bigger topic, which is our general regulations here, general requirements for electrical installations. And so here, what they're going to talk specifically about is electrical connections. And specifically what we're going to take a look at is the temperature limitations of electrical connections. Now, if I was looking for a test question and I couldn't find it, what I don't want to do is read through all of this stuff if I'm not looking for electrical connections, because everything under 110.14 is talking about electrical connections. So when we get to letter A, this is terminals for electrical connections. Letter B is splices for electrical connections. Letter C is temperature limitations for electrical connections. Now let's say what I was looking for was high leg marking. Well, then I can skip over everything that is under 110.14 and jump to 110.15. 110.15 is high leg marking. Okay, that's what I want to read. But let's say I was looking for arc flash hazard warning. Then I could say, oh, well, 110.14 is electrical connections. I don't need that. 110.15, that's high leg marking. I don't need to read that, right? And then I jump to 110.16, arc flash hazard warning. Okay, stop right there. Now we're going to read, okay? So one of the things that slows people down as they're looking through the code is they read a bunch of stuff that they don't need. So you don't read what you don't need, right? And so if I don't need to know about electrical connections to answer the question on the exam, I'm just going to skip it and go to the next topic. So by scanning those topics, we can move quickly through the code. All right? So let's get back to this 110.14 electrical connections, because there is something that we need to highlight here. Under letter C, temperature limitations, we've got number 1, equipment provisions. So these are equipment provisions for temperature limitations for electrical connections. We're going to jump down to number 4 down below there, and it says for motors marked with design letters B, C, or D, conductors having an insulation rating of 75 degrees or higher shall be permitted to be used. So I can use a 75 or a 90 degree conductor, okay? But let's read on. Provided that the ampacity of such conductors does not exceed the 75 degree ampacity. So normally a 90 degree conductor can carry more ampacity than the 75. And so if I was using a 90 degree conductor, normally I would use the 90 degree column on table 310.16. But because I'm connecting to a B, C, or D motor, and on that motor nameplate it'll say design letter B or C or D, then they're saying, hey, you can still use that 90 if you want, but I want you to size the ampacity using this 75 degree column. So this is just a piece of information that we're going to stick in our back pocket until we get to Article 430 and we're sizing conductors for motors. But if we do a B, C, or D motor, we're going to size that using the 75 degree column regardless of whether we're using a 75 degree conductor or a 90 degree conductor. Moving on, let's go to high leg marking. 110.15 high leg marking. It says on a 4-wire delta-connected system where the midpoint of one phase winding is grounded, only the conductor or bus bar having the higher phased voltage to ground shall be permanently and durably marked with an outer finish that's orange in color or by other effective means. So the high leg on a 4-wire delta-connected system can be marked indicating with color the high leg, and that would be orange in color. All right, or it says we can also use other effective means. So that could be just a tag on there that just says high leg. That would be okay if I don't have orange on the truck. Moving on, 110.16, speaking of orange, we've got arc flash hazard warning. So the picture there has got a sign with warning in orange. So our warning signs, we're going to talk about this here in just a little bit, but the warning signs need to have specific colorations, specific types of letters, sizes of those letters, and things like that. So here we're talking about an arc flash hazard warning. And so letter A, general. Electrical equipment such as switchboards, switchgear, enclosed panel boards, industrial control panels, meter socket enclosures, and motor control centers that is and other than a dwelling unit and is likely to require examination, adjustment, servicing, or maintenance while energized shall be field or factory marked to warn qualified persons of potential electrical arc flash hazards. So, if there is a potential for an arc flash hazard, we need to have some sort of warning sign on there, on or adjacent to the equipment. Let's move to 110.21 marking. And we're going to skip letter A, equipment markings, jump down to letter B, field applied hazard markings. Number 1 says the markings shall be of sufficient durability to withstand the environment involved and warn of the hazards using effective words, colors, symbols, or any combination of thereof. And so ANSI Z535 is actually where we find the regulations for the symbols and the colors and things like that. Here this is a warning sign. It's got a orange colored background to it, right? That's going to be something that's dictated by that. Same thing that we saw here on the previous sign, right? And then it says it needs to indicate the hazard that's involved. So back on the previous slide, we can see that it said, hey, the hazard that we're dealing with here is arc flash hazard, right? It also says, hey, we need to have appropriate PPE, personal protective equipment. And it says failure to comply can result in death or injury. So it says, hey, by the way, it's dangerous. By the way, this is an arc flash hazard, danger, right? And by the way, this can kill you, right? So we need to have appropriate marking on all of these different signs. And it needs to be durable enough to withstand the environment involved. So if I've got something that's exposed to weather, I need to have a label on there that can handle that type of exposure. Let's go down to part 2. So page 68, spilling on to 69. Part 2 is dealing with only installations that are 1,000 volts nominal or less. So remember, part 1 was general regulations. Now we're getting more specific. Hey, by the way, these regulations are only for 1,000 volts and under. And so we're going to take a look at 110.26, spaces about electrical equipment. And we're going to go to letter A, working space. Down below there, we're going to highlight working space for equipment operating at 1,000 volts nominal or less to ground and likely to require examination, adjustment, servicing, or maintenance while energized shall comply with the dimensions of 110.26A1, A2, A3, and A4, or is otherwise required or permitted in this code. So they're saying, hey, I need to not only comply with A1, which is the depth of the working space, but also A2, which is the width, and then A3, the height. So everything that's listed in here, we need to comply with all of that, not just one of the regulations. We're going to look specifically at A1, which is the depth of the working space. I call that the belly room, right? How much belly room do we need to have? It says, hey, if we're looking for the depth of the working space, refer to table 110.26A. And so we're going to take a look at that here next. And so table 110.26A1, that's our working spaces. And so we need to read all these different headings on there to kind of understand exactly what the table is talking about. So again, it's the depth of the working space, and that's going to vary depending on our voltage. So over on the left-hand side, we've got our nominal voltage to ground. And then we have a column that's condition 1, condition 2, and condition 3. Hey, that information's useless to us unless we know what condition 1, condition 2, and condition 3 are. And so down below the table there, it says under notes, these are our conditions. Condition 1 is I've got live parts on one side of the working space and no live or grounded parts on the other side of the working space. So all of my electrical live parts are going to be in front of me. And then condition 2 is I've got electrical live parts in front of me, but back behind me, everything is effectively grounded. And then condition 3 is I've got stuff in front of me and I've got stuff behind me that's live electrical parts. So when we take a look at this question here, the depth of the working space for a system operating at 480 volts with exposed live parts on one side of the working space and grounded parts on the other side is going to be what? Minimum, right? And so our minimum depth, the first thing we're going to have to take a look at is, hey, I've got 480 volts. And then the second thing is we've got live parts on one side of the working space and grounded parts on the other side of the working space, right? And so that would be condition 2. So 480 volts, condition 2. Now we're going to take that information to the table and flip back a couple of slides here. So that's going to take us down to the second row, 151 to 600. That'd tell us 480 volts. And then we go over to condition 2, and now that depth is going to be 3 foot 6 inches deep. So that's the minimum clear distance that we have for depth of our working space. Now A2 is dealing with the width of the working space. So how wide does it need to be? It says the width of the working space in front of the electrical equipment shall be the width of the equipment or 30 inches, whichever is greater. So it says also, it goes on to say, in all cases, the workspace shall permit at least 90-degree opening of equipment doors and hinged panels. So when we're taking this measurement, it's going to be based off of either the width of the equipment or 30 inches, whichever is greater. So let's say I have a 24-inch piece of equipment. 24 or 30, which one's bigger? 30. So the width in front of a 24-inch piece of equipment is going to be 30 inches. Now let's say I had 48-inch wide equipment. How wide do I need to be? Which one's bigger, 48 or 30? 48. It needs to be 48 wide. So it's 30 inches or the width of the equipment, whichever is greater. Now number 3, the height of the working space. Says the workspace shall be clear and extend from the grade floor or platform to a height of 6.5 feet or the height of the equipment, whichever is greater. Again, so our minimum is going to be 6.5 feet, but if I've got an 8-foot tall piece of equipment, the height of my working space in front of that electrical equipment is going to be 8 feet. Now, just as a clarification here, this is where we're going to have electrical parts that need to be serviced while energized. And so that's where this rule comes into play. That's under letter A, working space. It's where it's likely to be requiring service while energized. That's when these width, heights, and depths come into play. Let's go still under 110.26, spaces about electrical equipment. We got a letter C, entrance to and egress from the working space. And number 1 down below there, minimum required. It says at least one entrance of sufficient area shall be provided to give access to and egress from working space about electrical equipment. And so without any qualifications as to the size of the equipment, we do know that the voltage is 1,000 volts or less. Hey, I need to have one way at least to get in and out, right? Access to and egress from. Now, number 2, large equipment. It says for large equipment that contains overcurrent devices, switching devices, or control devices, there shall be one entrance to and egress from the required working space not less than 24 inches wide and 6.5 feet high at each end of the working space. So now they've clarified, hey, if I've got large equipment, not only do I need to have one on each side of the working space, but I also need them to be at least 24 inches wide and 6.5 feet high. And that's number 1 for equipment rated 1,200 amps or more or over 6 feet wide. So what's large equipment? That's equipment that's over 6 feet wide. Let's move to letter D. Still under 110.26, spaces about electrical equipment. We've got letter D, illumination. So this is the illumination of that electrical equipment. And again, in context specifically, electrical equipment, 1,000 volts or less. Letter D, illumination. Illumination shall be provided for all working spaces about service equipment, switchboard, switchgear, enclosed panel boards, or motor control centers installed indoors. Control by automatic means shall not be permitted. All right, so basically, if I've got electrical equipment, I got to be able to see it to service it, right? And so we need to have illumination of some sort in there. We're going to skip letter E, dedicated equipment space, and we're going to go down to letter F, locked electrical equipment rooms or enclosures. That'll probably take us on to the next page here. Electrical equipment rooms or enclosures housing electrical apparatus that are controlled by a lock shall be considered accessible to who? Qualified persons, the person with the key. And so we talked about accessible, we talked about readily accessible. This is going to be considered accessible to qualified persons. If it's a locked enclosure, we've got a key. Let's go to 110.27, guarding of live parts. And again, these live parts are going to be 1,000 volts or less. And so when we take a look at letter A, it says, except as elsewhere permitted or required by this code, live parts of electrical equipment operating at 50 to 1,000 volts nominal shall be guarded against accidental contact by approved enclosures or by any of the following means. Okay, so again, what do we need to do over 1,000 volts? That's addressed in another part. That's going to be in part 3. Okay, so again, part 2 only addresses 1,000 volts and less. So it says 50 to 1,000 volts. So one of the questions we start seeing on the exams is, at what voltage do we need to start guarding? And that's going to be at 50 volts. Now it says also it can be guarded by any of the following means. We're going to jump down to number 4. It says by an elevation above the floor or working surface as follows: a minimum of 8 feet for 50 volts to 300 volts between ungrounded conductors. And so one of the ways we can guard against that is by elevating it. How high do we need to elevate it? Depends on the voltage, right? If I'm not exceeding 300 volts, we can elevate that 8 feet, and that would be considered adequate guarding. Let's go to 110.31, enclosures for electrical installations. Now, here we got to pay attention. Hey, we just jumped into part 3. So we're no longer talking about 1,000 volts and under, right? Now we're talking about over 1,000 volts nominal, okay? So 110.31 is enclosures for electrical installations, and again, in context, these are only installations that are over 1,000 volts. We're going to skip down to the second paragraph, and it says, for installations other than equipment described in 110.31d, a wall, screen, or fence shall be used to enclose an outdoor electrical installation to deter access by persons who are not qualified. A fence shall not be less than 7 feet in height, or a combination of 6 feet or more of fence fabric and a foot or more of extension utilizing 3 or more strands of barbed wire or the equivalent. So it's saying in this installation that's enclosing electrical apparatus that's operating at over 1,000 volts, that fence needs to be 7 foot high. Or you can make it 7 foot high, right? 6 feet plus 1 feet is still 7 feet. Letter D, enclosed equipment accessible to unqualified persons. We're going to skip down a few lines in there. It says where equipment is accessible to unqualified persons and the bottom of the enclosure is less than 8 feet above the floor or grade level, the enclosure door or hinged cover shall be kept locked. So if I'm not elevating that up above 8 feet, right? We need to have that back behind some sort of locked cabinet or enclosure. 110.34, workspace and guarding. We're going to go down to letter C, locked rooms or enclosures. The entrance to all buildings, vaults, rooms, or enclosures containing exposed live parts or exposed conductors operating at over 1,000 volts nominal shall be kept locked unless such entrances are under the observation of qualified persons at all times. So we can have it locked, or we can have some sort of guard on duty guarding those electrical enclosures. Permanent and conspicuous danger signs shall be provided. The danger shall meet the requirements in 110.21b. Remember, it needs to withstand the environment involved and needs to be clearly marked as to the hazard. And it says it shall read as follows: danger, high voltage, keep out. We're going to skip part 4, which is tunnel installations, because it's not on the exam. And we're going to jump into part 5, manholes or other electrical enclosures intended for personnel entry. Now, it does not say the voltage on there, So the intention here is that's all voltages, okay? So that's going to include the stuff that's 1,000 volts or less and stuff that's over 1,000 volts. So we got 110.75 access to manholes. And letter A, dimensions. Rectangular access opening shall not be less than 26 inches by 22. Round access openings in a manhole shall not be less than 26 inches in diameter. Now, look down below here, we've got an exception to that. So minimum round is going to be 26 inches, except a manhole that has a fixed ladder that does not obstruct the opening, or that contains only one or more of the following, shall be permitted to reduce the minimum cover diameter to 2 feet. So if I've got a fixed ladder, or if I've got any of these cables or any mixture of these cables down in the manhole, then we can reduce that down from 26 inches down to 22 or 24 inches. That's going to be optical fiber cables, power limited fire alarm cables, or class 2 or class 3 remote control signaling circuits, or both, supplied in accordance with 725.60. And so if I've got a fixed ladder, doesn't matter what kind of cables I have in there, I can reduce that down to 2 feet. If I've only got optical fiber cables down in there, no fixed ladder, I can still reduce it down to 2 feet. So the key word is there, or, right? If I've got a fixed ladder, or if I've got these cables, now I can reduce that down to 2 feet. Let's move on under still 110.75 access to manholes. We're going to talk about the covers on the manholes. Letter D, covers. The covers shall be over 100 pounds or otherwise designed to require the use of tools to open. They shall be designed or restrained so that they cannot fall into the manhole or protrude sufficiently to contact electrical conductors or equipment within the manhole. And that's typically why we see that manhole cover being round, because a rectangular manhole cover can fall into the opening, but a round will never fall into the opening. And that cover needs to weigh at least how much? It says over 100 pounds. I think on the test, most often they say what's the minimum weight for a manhole cover, and the highest choice is 100 pounds on the thing. Now, that's not technically correct, but it's the only one that makes sense. They're trying to get to that 100 pounds. But really what the code says, it needs to be over 100 pounds. How much over? I don't know. An ounce, right? Just over 100 pounds. Let's go to 110.79. This is going to be the last thing we cover here in this article. Fixed ladders. So I got fixed ladders that are going to go into a manhole. How do I know that? Because we're in part 5, manholes. Okay? So fixed ladders shall be corrosion resistant. So if I've got a fixed ladder going into a manhole, it needs to be of corrosion resistant construction.